Space is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you might think it's a long way down the road to the chemists, but that's just peanuts to space. We're going to be looking at the size of space, the size of the universe, and what's in it. So I'm going to show you some pictures and tell you some things, and I'm going to ask you some questions. The questions are repeated in the document that you've got, so you can answer them there. You can watch the video all the way through, or you can pause it. It's up to you. This is a picture of some of the stars that we can see in the night sky, just to show how vastly bigger than the sun they actually are. And if you watch one of the videos that I've sent you a link, you'll see a much better version of this. Have a look at these objects in space. So one of your first questions is, look at all these things, the universe, a planet, a comet, a star, a galaxy and a cluster, and put them in order from largest to smallest. Here's another picture of the solar system showing how much smaller all the planets are than the sun. Three things: the Earth, the universe and the sun. Can you match them to their age? We'll explain how we know these ages at a later time. If you look up at the night sky on a clear night and you're away from streetlights, you see this. This is the Milky Way. It's our galaxy, but it's viewed from within. We're looking at it end on because we're in it, looking towards the centre of it. But if it's full of 500 billion stars like we suppose, why isn't it any brighter than this? See if you can find out the answer. When you look up at the night sky and you see all those stars, all but one of them are in that little yellow circle there. We can't see any stars further away, they're just too distant. But we can see Andromeda, the galaxy Andromeda, and that's what I want you to see if you can find in the night sky over the next week. This is what we think the Milky Way would look like end on. All the stars that we see in the night sky are in that little red circle there on the right. And it takes light 100,000 years to cross from one side to the other. This is a picture taken by the Hubble Space Telescope. They targeted it on a point near the moon, that little red square there, and what looks like to us from Earth as being a little square of blackness, to the Hubble Space Telescope they saw hundreds of millions of galaxies, each one having hundreds of millions or billions of stars within them. Back in our own neck of the woods, here are 4 of the planets in the solar system. There's more than 4, of course. See if you can name them. But these are the rocky planets, the ones that aren't made of gas, the ones that are nearest to the sun. And let's have a close-up and look what the surface is like on some of them. This is Mars. Sunrise on Mars. It's a lot colder than Earth. A dry, frozen desert. This is sunset on Mars. These photos are taken by the various robots that roam the surface of Mars. In fact, Mars is the only planet that we know in the known universe that is inhabited entirely by robots who walk around there taking photos and doing samples for us. This is what Earth looks like from Mars, a distant little dot. And this is what the Milky Way galaxy looks like from Mars. And as you know, this is the first picture of water on Mars. And this is the only one of 2 pictures of the surface of Venus. The Viking landed there in 1976, and it only took 2 pictures because of 600 degrees Celsius and sulfuric acid rain. It was destroyed, but it managed to send back this picture. That thing in the front ground is its foot. Or whenever you get a lander or a robot to land on a planet, you always take a picture of the feet first so you can see what you're standing on. This is a picture of us, of Earth. There we are, that little pale blue dot. And this was taken by Voyager just before it left the solar system as it passed Saturn. It was turned around, its last photo, to take a picture of Earth. There it is. Hang on, was anything in this picture? Oh yeah, empty space, but on the left is the Earth and on the right is the Moon. This is to scale. This is a picture to scale. How big the Earth is compared to the Moon and how far apart they are, 250,000 miles. It's quite a long way, big enough to fit all the other planets of the solar system inside it. This is a picture of, if we got all the surfaces of all the planets and spread them out flat, then this is how much surface they have, planets and moons in this case. So you can see that Earth has quite a large surface area, similar to Venus, but all the other planets and moons are much smaller. Now here's a few fun comparisons. If the Earth was a football and had it in the lab, the Sun would be how big and where would it be? It would be 3 miles wide and it would be in Robin Hood's Bay. If the Sun was an orange and it was in the lab, how far away would the Earth be and how big would it be? It would be the size of a pinhead and it would be out by the stable's gate. If the Sun was an orange and it was in the lab, on the same scale, Jupiter would be, any guesses? Be the size of a marble and it would be in the sports hall. If the Sun was an orange in the lab, the nearest star, which is Alpha Centauri, how far away would it be? It would be New York. So you get to get the picture of how small things are compared to the vast. Now when you switch on a light, it appears to come on straight away and it lights the room instantly, but that light does take a little bit of time to get there, even though it's very quick. And the speed of light we know is 300 million meters per second, and we write that as 3 times 10 to the 8 meters per second. So that's 3 with 8 zeros after it. So here's a question for you. The Sun is 149,600,000,000 meters away. So how long does it take for the light to reach us? So if you can write your numbers, write the sum in the on the assignment document. Speed of light is 3 times 10 to the 8. The Moon is 384,400,000 meters away. How long does the light take to reach us from the Moon, reflected back? And the nearest star is Alpha Centauri. It's actually a double star. It's Proxima Centauri and Alpha Centauri. There's 2 stars together. And it's 4.3 light years away. The nearest galaxy, Andromeda, is 2.5 million light years away. How long will it take for light to get from those 2 places to us, from Alpha Centauri to us and from Andromeda to us? What is a light year? A light year is the distance it takes, a distance light will travel in a year. Because it's moving at 300 million meters per second, that's how much ground it covers, how much space it covers in that time. And it covers that number, which I'm not even going to say, I can't remember how to say it, but 9.5 times 10 to the 15 meters every year. And we call that distance a light year, the distance that light travels in a year. And it takes 4 years for light to travel across the solar system. So we say the distance is 4 light years. And it takes 100,000 years to cross the Milky Way galaxy. So we would say the Milky Way galaxy is 100 light years across. Right, so we got this question again. How long does it take light to get to Alpha Centauri or back from Alpha Centauri and back from Andromeda? We mentioned that. Let's see if you can work out how long it would take a rocket traveling at the fastest speed that we can make a rocket travel at. How long would it take to get to Alpha Centauri and to Andromeda if they're 4.3 light years away and 2.5 million light years away? See if you can do that one. You can figure that out for yourself. Right. Penultimate question for you. In what way is a telescope like a time machine? Write a couple of sentences on that. And this is the penultimate question, I think. So, can you sum up what we've talked about so far for your project? In answer to this question, someone's written to a magazine and said, "Dear Astronut, I once read in a book that space was big. Just how big is it and what's in it? Tell me, Marvin." So, can you do it? Have a go. See if you can summarise what we've been talking about in this. And here's the final question for you. And this leads on to something we'll talk about another time. How long exactly is a day? How do we know? I'll give you a clue. There are two ways of doing it, and they both give different answers. How long is a day? Exactly. And if you do get outside and there is a clear night, get your night sky journal out and see if you can locate where Andromeda is. But report anything else you see. I was looking for the shooting stars last week, and I stayed out for a couple of hours, but I only saw one, which is a bit disappointing. So I think they probably peaked in the early hours. But I saw one, but it was the greatest shooting star I'd ever seen. It was a proper fireball. It looked like a spaceship was crashing through the atmosphere and burning up and spinning. It was pretty impressive, but sadly just the one. But see what you can see during the week. And finally, here's a summary of what we've talked about in this session. Do you agree with this sentiment? Talk soon.